I hope my screen is visible. Type yes in the chat box. Okay. Okay, Darshan. Okay, Ganesh. Okay, Darshan. Let us do a small recap about the yesterday's topic. We were discussing about the number systems in Java. There are four significant number systems. One is the decimal number system, binary, octal, and hexadecimal number system. So each and every number system is going to get represented with the base value. If the base value is 10, like it is called a decimal number, and the 2 goes for binary number system, and the 8 for octal, and 16 for hexadecimal. Very self-explanatory, right? And I was saying that any raw data, when you come across any raw data is a real-time data. It has its own identification. Any real-time data that the human can understand, we call it as raw data. That data can be in the form of numerical values, it can be in the form of sequence of characters, it can be in the form of a film song, or it can be in the form of video. Anything that is, that the humans can understand is called as a raw data. So the raw data typically gets converted in the form of bits, the form of binary numbers, right? Even if you want to save a numerical value, this numerical value will get converted to the binary number, equivalent binary number, and it will be stored inside the computer. You cannot literally, one cannot store the actual data. The data needs to be converted into binary numbers. Binary numbers are nothing but the numbers that can be understandable by the computers. They understand only zeros and ones. So even if you want to save any movie, the movie will be broken into bits and pieces, and it gets converted into zeros and ones. How the conversion happens, we are going to see that. But literally, the computer world, any computer, any electronic products, they are going to handle data in the form of zeros and ones. So understanding binary number system is very important, because that is how the data gets stored inside the computer. And if you want to retrieve the stored data, so the stored data again will be converted back to its equivalent raw data. So internally there will be a lot of compilers, there will be a lot of translators. So many things will be there internally, but the takeaway is the computer is going to accept the data in the form of zeros and ones. It's going to accept only binary data, which is in the form of zeros and ones. So this was just the introduction about the binary number system, and so this is what I have explained to you about the binary number system. All the raw data that is understandable by the humans will get converted to the respective binary data, which is nothing but zeros and ones, which is understandable by a machine. So it performs the respective operations or manipulations on top of this data. So we have discussed about the decimal number system. This is how a decimal number can be represented with the base 10. Right? If you split this number, right, you can split it the way you pronounce. For example, 757 can be pronounced as 757. So the way you pronounce it, it can be splitted in the way you pronounce, right? And again, the number that is split, it can be converted to the equivalent power of the base value. So the significance of the power will be increased from right to left. So the most significant, the least significant digit. So the digit that is placed towards the complete right side is called as the least significant digit. And if you keep adding powers, the significance of the power will go from 0 to the positive number, like 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and it keeps those on, depending upon the number of digits that you have. Again, if you evaluate this, you are going to get the same number. Why it is base 10? Because with the multiples of 10, you can rewrite the number with the multiples of 10. You can divide the number with the multiples of 10. Right? So this is the equivalent conversion. 757 again can be converted into 757. You can split the number with the multiples of 10 according to the significance. 10 to the power of 0, 10 to the power of 1, 10 to the power of, right? This is all about decimal number system. Decimal number system is pretty simple to understand. The numbers that are understandable by humans, they are called as a decimal number system. As simple as that. It is always going to be base 10 because it accepts numbers from 0 to 9. You cannot see any other numbers apart from 0 to 9. Right? And we have started discussing about binary number system. Before even understanding about the binary number system, I have explained you about the smallest bit. A bit is the smallest unit of memory that you could store in a computer. Smallest piece of memory. Smallest piece of memory is nothing but a bit. So again, if you take a bit, if you say that your RAM capacity is 1 bit, it means that your RAM is going to store either one of these values. It can either store 0 or it can either store 1. Potentially it is capable to store two values, but at any given point of time, one number can be stored. One in the sense either you can store 0 or you can store 1. This 0 can also be called as a false. You can also rewrite it as no, or you can also say it as off. And 1 can be rewritten as true, yes, or it can also be called as on. So when you say 1 bit, if your system is having 1 bit of memory, it means potentially you can store two values. These are the values. These are one of the values, and these are the other set of values. So you can store 0 or you can store 1. 1 bit of memory is going to store any one value among these two potentials. Right? So the real-time example is if you want to communicate, if you want to establish a communication between two persons, one person is living in a city and the second person is living in a forest. You want to use 1 bit communication. 1 bit in the sense, with the help of switches and bulb, you can transmit two sets of data. One is you can turn on the bulb, you can turn off the bulb. Turning on the bulb can represent that you are in danger. Turning off the bulb can represent that you are safe. So two pieces of information can be transferred with one bulb. I mean, with a switch and with a bulb. So that is equivalent to this operation is equivalent to 1 bit. Right? If you have one switch, if you have one bulb, you can potentially send two kinds of information. One, you can either tell your friend that you are in the safer side, so you do not have to turn on the bulb. If you are in danger, you will turn on the switch, and turning on the switch, like since the connection is already established, it is going to give an information to your friend that you are in trouble. If you turn off the switch, you are safe. Right? With the help of a switch and with the help of a bulb, an information is getting transmitted. A communication is happening. The communication is established. So this is a typical way of representing the 1 bit information, 1 bit memory. This is external representation, external analogy. But if you want to represent the same thing in the computers, you use 1 bit. Internally, computers are going to use a transistor, and we are not going to understand what is a transistor. In the simple way, a transistor is going to have going to display two kinds of information. One is turning on the transistor, second one is turning off the transistor. So depending upon the signal, you can decipher or you can decode the output. You will understand this better by understanding the binary number system. So this is a typical example, right? So 1 bit can store potentially can send two pieces of information. If you go to 2 bits, it can potentially send 4 pieces of information. 3 bits, it is going to send 8 pieces of information, and it keeps increasing according to the number of bits that you're going to use. So this is a straightforward recap that we have discussed yesterday. So we'll see more about the binary number system, and it's important. Let us discuss this. Binary number system. Binary number system. Let us say that I have a number 45. I have a number 45. So 45 is a decimal number. It's a raw data, a complete decimal number where you can understand, where I can understand. If I want to store this number in my computer. In my computer, if I say computer, I always say about the RAM. So RAM is a typical storage device. What RAM is a typical storage device? It is a temporary storage device that you come across in any electronic system. So we are going to talk about the temporary storage devices, which is nothing but RAM. So this is how the RAM looks like. Let me this RAM is going to have a lot of transistors. So I just want to store 45 into this RAM. So I cannot directly store this inside my RAM. Firstly, I need to convert this 45 into its equivalent binary number. So this 45 is a decimal number. I need to convert it to the equivalent binary number. I know you already know the conversion. For people who don't know, let me explain you that. So this is the decimal number system. 45 with base 10. If I want this number to be converted to the equivalent binary system, I will keep dividing this number by 2. So 45 will get divided by 2 as long as the number becomes 1. What do I mean by that? So let me divide the 45 by 2. So 2 is 44, the remainder is going to be 1. I will keep dividing it by 2 as long as I get 1. I get the remainder 1. So again divide it by 2 11 times. So remainder is going to be 0. I will divide it by 2 5. Remainder is going to be 1. 2 2 4. Remainder is going to be 1. Again 2 2 ones are 2. Remainder is going to be 0. Right? So I need to divide it until I get the remainder as 1, the last remainder as 1. I will rewrite this number from bottom to top sequence. So in this case, the number is going to be 1 0 1 1 0 1. So this is how the 45, the decimal number, is getting converted into its equivalent binary number. Now this number can be stored inside my RAM. RAM accepts this kind of information, zeros and ones. Right? Now I can store this data. Now data is what? 1 0 1 1 0 1. I can store this information directly into my RAM. Right? So this is the binary number I can store. Likewise, if I want to store any other number, if I want to perform any manipulations, for example, let me take, if I have a number like, we want to do addition operation between two numbers. We want to add two numbers, 10 plus 15. Right? By using computer, I want to add these two numbers. So we as human beings, we know the answer of 10 plus 15 is going to be what? 25. But I want computer to perform this operation. So firstly, computer will not accept this data directly. It will ensure that each and every decimal number is getting converted to its equivalent binary representation. So first, this 10 will be converted to binary number. Right? So you will have to keep dividing it by 2. I think I know you. I am assuming that you know this conversion. 2 5 is 10 0. 2 2 is 4, remainder 1, 2 1s 2, remainder 0. So the 10, the decimal number 10 and its equivalent binary representation is 1 0 1 0 base 2. Secondly, 15. Again 15 needs a conversion, right? 7 times 14, so remainder is 1. 3 times 6, remainder is 1. 1 times 2, remainder is 1. Right? So the equivalent binary representation of 15 is what? 1 1 1 1. right? Now the RAM is going to accept these two values. So these two values, it will be accepted by the RAM, and RAM will perform the addition operation. It won't perform the application directly on these decimal numbers. It will perform the additional operation by converting the numbers to its equivalent binary format. Then it will perform the addition operation, right? So if you want to do the addition operation, so the 0 and 1, 0 1 1. So if you want to add two binary numbers, so this is how the binary numbers work. 0 plus 0 is going to be 0, 1 plus 0 1, 0 plus 1 is also 1, and if you add 1 plus 1, it is going to be 10, right? In binary, 1 plus 1 is going to be 10. So we need to follow these rules, binary additions. I'm assuming that you know all this, and I'm trying to give the explanation, so you will understand it, why this explanation is necessary. After a few minutes, you will understand why these things are necessary. I'm just adding 0 and 1 1. 1 plus 1 is going to be 10 again. Again 1 plus 1 is going to be 10 again. So 1 plus 1 is 10. 1 plus 1 is 10. Again 10 plus 1 is going to be 11. So this is the equivalent binary representation of adding 10 plus 15. Right? So the answer is 1 1 0 0 1. It has calculated this, and we need to convert this into the, and the RAM will be converting this number into the equivalent decimal representation to display it in the console, because our requirement is to add 10 plus 15. It will go inside the RAM as binary values. The RAM will accept binary values of 10 and binary values of 15, and it will perform calculations on top of these binary values, and while giving output or while displaying this output in the console, again the binary values will be converted to the equivalent decimal representation. So this binary value has to get converted to the equivalent decimal representation. How do the conversion happens now? That's the question, right? Very simple. Just try to use the significant powers of 2. What do you mean by significant powers of 2? Just start writing 2 to the power of 0, 2 to the power of 1 in the increasing order. 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. So each and every placeholder, from the least significant bit to the most significant bit, from right to left, keep writing the values of powers in increasing order. So 2 to the power of 0, 1, start from 2 to the power of 0 and keep increasing it as long as you find the last bit. So here I have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Right? And add and perform the addition operation for the one bit's number. In this case, we can see three numbers that represent 1 bit, right? Take that equivalent 2 to the power of the power value. So in this case, 2 to the power of 4 is what? 16, and plus 2 to the power of 3 is what? 8. Ignore this, because 0, ignore 0, ignore 0, and again this is 1. 2 to the power of 0. 2 to the power of 0 is what? 1. So the answer is going to be what? 16 plus 8, 24, 24 plus 1, 25. So this will be displayed in the console. This will be displayed in the system console. So what is happening internally? Whatever the number that you are giving, the number will get converted to the equivalent decimal number will get converted to the equivalent binary number, right? And if you want to perform addition operation, this addition operations will be performed on the binary numbers, and after performing addition operations on the binary numbers, this binary number again will get converted to the equivalent decimal number, and it will be displayed in the console. This is for the simple addition operation. For simple addition operation, these binary calculations are happening internally. Right? Not only for the addition, if you want to do any kind of calculations, if you want to do multiplication, if you want to do division, whatever the calculation that you are trying to perform by using computers, internally the binary conversion is happening. As simple as that. So this is the importance of binary number system. So this is just for the basic calculations, right? The basic calculations are happening inside with the help of binary number system. So what I'm saying is, not only these basic calculations, whatever the data that you pass, any data, any raw data like audio, like video, like what we call it as, like your name. Let us say if we want to, if I am passing name as Balaji, this Balaji will be getting converted into the equivalent binary number. How that conversion is happening, we will analyze those conversions in the data types. We have a concept called data types. Right now, for the time being, just understand that this is how the numbers gets converted internally with the help of binary number system. This is the significance of binary number system. Right, the RAM accepts the binary values, as simple as that. Right now, so let me introduce a few more. Okay, binary number system is okay, and on top of binary number system, with this understanding, we can able to understand about the primitive data types in Java. Primitive data types in Java. I will tell you what is a primitive data type, but primitive data types are used to allocate memory. So the data types that are used to allocate some memory for the end user and for the developer is called as what? Primitive data types. So there are 8 primitive data types in Java. What are they? Byte, short, int, long, float, double, character, boolean. Each and every primitive data type is going to consume some memory. It is designed in such a way that it is going to consume some memory internally. Right? If you say byte, if you want to store some data by using byte data type, this byte data type is designed in such a way that it is going to consume some memory. How much memory it is going to consume? It is going to consume 1 byte of memory. Likewise, you take short. If you want to store a data by using short data type, it is going to consume some memory. How much memory? 2 byte. And long. I will explain you why there is some differentiation in allocating memory. Why Java people has come to this conclusion? Why Java people wanted us to use data types? Why they want us to use these specific data types in order to store some values? We will arrive to that conclusion, but try to understand that when you say byte is going to consume 1 byte of memory, short is going to consume 2 byte of memory, and int is going to consume 4 byte of memory. Long is going to consume 8 byte of memory. This consumption is very fixed. It will not change. It will, even whatever the laptop, whatever the system that you are going to use, no matter what system you are going to use, Java will ensure that, okay, if the developer is trying to use long data type, occupy 8 bytes of memory. Right? Even though if you use Mac operating system, if you use Linux operating system, if you use Windows operating system, no matter what operating system you are going to use, the memory consumption is going to be same for all operating systems. That is the specialty about Java. Float, again float 4 bytes, double 8 bytes. Character is going to consume 2 bytes. Boolean is going to consume 1 bit. Only 1 bit. So this is how the memory is consumed. So 1 byte we can also call 1 byte as what? 1 byte can also be converted to 8 bits. If I say 1 byte, it is equivalent to consuming 8 bits of memory. Just multiply it by 8. 2 bytes means just multiply it by 8, 16 bits. Right? 4 bytes, 32 bits. 8 byte, 64 bits. Just multiply it by it. You will get the number of bits that it is going to consume. 4 bytes. Again what? 32 bits. 8 bytes, 64 bits. 2 bytes, 16 bits. So 1 bit is always equal to 1 because it is already given in the given as a single bit. So it is 1 bit itself. So there are no further conversion is required. So 1 byte is equivalent to 8 bits. So we are just multiplying it by 8 to get the value of bytes into bits. Just multiply it by 8, as simple as that. So when I say 1 byte, it is 8. If I want to take real-time analogy, for example, let us say that you are going to a restaurant. You are going to a restaurant and you would like to order some tea. Right? When you order some tea, the tea is going to be like 100 ml or 150 ml, isn't it? What if the restaurant guides, if they are serving you tea in bucket, instead of serving you the tea 150 ml of tea in a cup, what if they serve you the same 150 ml of tea in a big bucket? The bucket is going to occupy at least 10 liters of tea, right? It can occupy 10 liters of tea. More space is there. But it won't be feasible or it won't be relevant if they serve you the quantity in the bucket, right? Why it is not relevant? Firstly, it is the bucket is like it is a very big thing. You cannot handle it, you cannot hold it, and you cannot sip the 100 ml of tea from the bucket. It won't be good. Secondly, for 100 ml or for 150 ml, one is a medium sized glass would be sufficient, because that is how this capacity of the tea can be can hold, can a single cup can hold. Right? It would be very feasible if the tea is served in a big medium sized cup, or a very big cup. The size of the cup can be 200 ml, and they can serve 150 ml of tea in the 200 ml size of cup. That would be completely feasible. But serving the same quantity of tea in a bucket, it won't be feasible, right? It will not make any sense, right? Why it will not make any sense? We humans, we know it is going to consume a lot of space for small amount of quantity. For small amount of quantity, the bucket can hold that quantity, but it is not feasible. Why it is not feasible? It is going to consume a lot of space. I mean, a lot of space will be wasted, and you as the consumer will not feel like to sipping the tea, right? It will be very difficult. Memory is wasted, space is wasted, capacity is not completely utilized, right? Buckets are meant to be used in the restrooms, right? Because its capacity more, and you can hold liters of water, but not milliliters of tea, right? Likewise, if you want to store a specific data, that is going to consume less amount of memory, you choose byte, right? If you want to store numbers that starts from that is less than 150, or that is less than number that is less than 120, you can use byte. Small numbers, to store small numbers, you can use byte. But then again, to store a number that is less than 120, you can also choose long data type, but there will be lot of memory wastage. It is just like serving the tea by using a bucket. I hope you are able to correlate this example, right? That's why in Java they have differentiated, and they have come to like define the data types in these 8 subcategories. If you have any data, if you have a small amount of data, go for byte. If you feel that the data that you are going to store is a little like bigger than byte, go for short. If it is bigger than short, go for int. If it is bigger than int, go for long, right? So these 4 data types are falling under one specific category. Only you can store numbers, complete whole numbers without any fractional part. You can store positive numbers, negative numbers, but it should be a complete whole number without any fractions, without any floating points, without any precisions. What do you mean by that? You can store numbers like 100 or minus 100 or minus 1000, right? Or maybe any bigger number, no problem. But you cannot store numbers like 100 point something. any precision values cannot be stored here. Any floating points, if you want to store any floating points, these data types are not recommended. For that, for floating point numbers, you will be forced to choose either float or double. So any numbers that has high precision in the sense you want to store a data that has where you want to include the floating point values also, where you cannot ignore the floating point values also. See, if you go to any store, sometimes the bill would be in the amount of 105 rupees 75 paise, right? So in the supermarkets, they don't round off that. They will round off that paise the higher value. If you know what I mean. If it is 100.75 in supermarkets, they are okay to round it off like 101 rupees, right, to the bigger value. So rounding off is there. They will not ignore the 75 paise because they consider that 75 paise is going to affect their tally. The offense affects their tally when they are shutting down the shop. So the calculation should be in should follow the good perfection. The calculation should be tallied at the end of the day, right? So these pieces will not be ignored even if you try to withdraw any amount from your bank. In bank, people will maintain the precision. The balance will be maintained in such a precision that they will not ignore these pieces also, right? If you have any such data like decimal that has any decimal values, you are allowed to choose either float or double, right? For any petrol price, every day you come across the petrol prices, right? So the petrol price is variable. Today it could be 102.75, tomorrow it could be 103.05, right? It varies with high precision. They cannot even ignore this paise, right? Rupees along with the paise. So this is the high precision data. This cannot be ignored. They cannot just say 103. They can say 103.89 with the high accuracy. If you have any such data, go for this. So this character data, this char data is going to, you can use this data to store any single character in single quotation, in single quotes. Any character, for example, my character, I cannot store Balaji. Instead of that, I can store B. Any single character with single quotes. Any single character with single quote. And not only these characters, you can store any data from any other language. If you want to store the letter A in Tamil, A. What is A? This is A, right, in Tamil. You can store this also in Java with the help of this character. They call it as Unicode representative. I will show you. In the future classes, we will get to know how the Tamil letters can be stored in Java. Even the Telugu letter A, this can also be stored in Java. All the major language, all the official languages in the world is supported by Java. In the Hindi letter A, you can store in Java. Single letter with single quotes. So you can store this with the help of the character data type. And if you talk about Boolean is going to, its memory capacity is 1 bit. Yesterday I have discussed about the 1 bit memory capacity. What did I just discuss yesterday? I said that in a 1 bit you can store either 1 or 0, and if you want to represent 1 can also be represented as true, and 0 can be represented as what? False. 1 bit is nothing but it can take either 1, it can also take 0, right? 1 can also be represented as true, and 0 can also be represented as false. So literally this Boolean data representation can either store true or false. Internally the true is nothing but 1 and the false is nothing but 0. So these are the 8 primitive data types that is made available to the developers by default. When you say data type, you are talking about the capacity, internal memory capacity. Just like the teacup, right? The teacup is going to hold 150 ml of tea. The bucket can hold 15 liters of water, right? And a barrel can hold 148 liters of oil, right? Depends upon the capacity of the particular instrument or capacity of the particular object, right? You can use that capacity to store whatever it is. In the real time, I have explained about T. Likewise, if you take any weight machines, right, each and every weight machine or each and every weight set is going to represent a specific weight. According to that, what you can purchase the raw materials in the supermarket. You can purchase vegetables according to that weight. The space, the consumption of a particular space, the real time, the same consumption. If you talk in the computer world, you're talking about what? Memory. This is how the memory can be represented. Each and every set of memory can be utilized by using this primitive data types. Primitive data types are nothing but what? The memory allocation inside Java. We'll understand this one by one. When I say one byte is going to store 8 bits of memory. So 8 bits of memory means it is a limited memory. 16-bit means a little bit more memory. 32-bit means you will get more memory than short memory. 64 means a super high memory, a super high memory. So it won't be, it will not make any sense if you want to store a value like 10 in by using long data type. It will not make any sense. It is just like serving the tea in a bucket. Hope making sense. Memory wastage will be there. So the more memory utilization depends upon how effectively you are going to store the data. The more memory utilization depends upon how effectively the data is stored, right? And each and every data type has some ranges, right? I do not want to give these ranges directly. I will understand, I will help you out through some binary calculations to get this range information, right? If you talk about these ranges, each and every data type has some ranges, but I do not want to give you these ranges directly, because it is just like memorizing these ranges. I do not want you to memorize these ranges. Instead, I will help you out with some calculations where you can evaluate these ranges by yourself. So literally, if you talk about byte data type, the byte ranges from -128 to +127. So this is what the documentation says. The documentation, Java documentation says, in the byte data type, if you want to store any values that is in between 128 to -128 to +127, you can use byte, right? If you want to store any values that ranges between 32,768 to 32,767, you can go for short. Likewise for integer, and it keeps increasing. It keeps increasing, but it will not make any sense if you memorize these things. If you memorize these things, it won't make any sense, because I will give you these calculations. We will arrive to these calculations by doing some manipulations. I will help you to arrive to these calculations, to arrive to these values. How they have arrived to these values, I will help you with that information. So likewise, if you go for long, so each and every data type has some ranges. If you have any data, like if you want to store any data that is falling in between these values, you can choose byte. If it is a larger data, you can go for short. Likewise, it keeps increasing depending upon the number of bits it is, number of bytes it is using internally. Right? Just type S in the chat box if you have understood till now. Still, we haven't started discussing about the data types. I have just given you the plain introduction. What is a byte, what is a short, and why these differentiations are there in Java, why this many data types are there in Java. I have just given you the brief illustration. It doesn't mean that we have completed this. We are just getting started. Right? Are you able to follow this? Okay. Okay, then we are good to go. So far we have understood the binary number system. So the just we have discussed about decimal to binary conversion, binary to decimal conversion. Internally, all the data in the RAM is going to accept, or RAM is going to store data in the form of binary numbers. That is the first conclusion, right? So if you want to represent data, all the data can be represented in the form of data types. This is given by Java. So there are 8 data types in Java. By its short, these are the primitive, and again we have another category called non-primitive data types, where you will be storing data like a sequence of characters, a very big what we call it as a very big raw data. So this data, the primitive data types are limited to numbers and characters, a single character, numbers and single characters, and the boolean value. Again we have a data type called non-primitive data types. Over there we will be storing a huge amount of huge sequence of characters, like your name, your address, right? These are the things that requires a lot of space. So to do that we go for non-primitive data types. First we need to understand what is primitive data type, right? So let us talk about this byte. Let us understand about this byte data type. Yesterday I have already said that 1 bit is the smallest representation. 1 bit is what? 1 bit is the smallest space that can be utilized to store a piece of information, right? By using 1 bit, you can either store 1 or you can either store 0. Two potential values are possible. Example, as example, it is visibly seen here, true and false. The Boolean data type is going to have a memory capacity of 1 bit. It means it can either store 1 or 0. 1 is also called as true, 0 is also called as false, right? But when I see the byte data type is potential enough to store 8 bits of memory. 1 byte of memory is nothing but 8 bits. So let me take 8 bits here. So this is 1 bit. So this is how the 8 bits look. Let me delete this. This is how the 8-bit representation looks like. 1, 2, 3, 4, 5, 6. Totally 8 boxes. 1, 2, 3, 4, 5, 6, 7. When I say 8 bits or when I say 1 byte, this is how the memory boxes are created inside the RAM. So this talks about, this is going to talk about 8 bits or 1 byte. 1 byte of memory or 8 bits of memory. This many spaces I have. So how many possible combinations that I can store by using 1 byte of memory or 8 bits of memory? There will be many possible combinations. You will understand each and every possible combinations, right? And we will also understand the ones complement. You will also understand the twos complement and significance of twos complement. Because you must understand one more thing. If when I say byte is not going to store only the positive values. It is also going to store what? The negative value. The range is already specified here. The Java documentation says the byte is going to store values that ranges from 128, negative 128 to positive 127. How did they arrive to this conclusion? We must understand this. Why it is still why it starts from minus 128? Why not minus 29? Right? Why it ends exact at 127? How this conclusion is arrived? Right? We need to understand this. Right? To understand this, I have just like showing a diagrammatic illustration of 8 bits memory representation. This is how the 8 bits looks like, right? Let me copy this. we will understand each and every combination. So these 8 bits can be like I can keep copying and pasting these 8 bits like this for a better understanding. Okay, I have multiplied this. Okay, see how many combinations of data that we can store by using 8 bits. First value can be like this: 0 0 0 0 0 0 0 1, and it keeps going like this: 0 0 0 0 0 1 0 0 0 0 0 0 0 1 1 0 0 0 0 0 0 1 0 0. Like this, I can keep calculating the combinations, right? 1 0 1 0 1 1 0. Like this, it keeps going. At one point, everything is going to be 1 1. I hope you are able to understand. At one point of time, every block is going to be what? Filled with 1 1 1 1 1. Right? So I have skipped so many steps here. So the idea is very simple. It starts from 1. This is the first combination. You want to store the number 1. Number 1, if you want to store the number 1 from decimal to binary, this is a decimal 1. You want to convert this to binary. This is how it can be converted. 0. All boxes get 0 except the first box 1. If you want to store number 2, so this is the number 2. Likewise, number 3. Likewise, this is the number 4. This is the number 5. Number 6. Right? And at one point of time, every box will be filled with 1 1 1. So what could be the highest value of this? Let's calculate that. 2 to the power of this is 2 to the power of 0, to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. 128. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Calculate all this. How much is the answer? 128 plus 64 plus 32 plus 16 plus 8 plus. Do some calculation. Anyone? One 27 plus 128. 255, isn't it? Am I correct? Yeah, 255. So 255 potential values that we can store. Right? With the help of 8 bits, we can store 255 values. So directly if I have a number like 255, I am good to choose byte data type. But the documentation says, sorry brother, in the byte data type you can store only the values from 128 to minus 128 to plus 127. Right? But my calculation says it is going to store 255. This is my calculation, but the document says the numbers from minus 128 to plus 127. These are the limitations for the byte data type. You need to understand this conclusion, because You and me, we can compare, we can understand that the positive sign and the negative sign. So by looking at a particular number, you can say that, okay, this is a positive number. We can differentiate between positive and negative numbers. But how the system can able to do the same conversion, or system can able to understand the same differentiation, right? If you want to say that a particular number is a negative number to the system, how this binary representation can able to differentiate a negative number? How we can save a number that is how we can save a negative number in a system? That understanding is required, right? So here my assumption is this: if I want to store only positive numbers, my calculation is correct. If I want to store only positive numbers, I can store up to 255. But the computer wants us to utilize the negative numbers also, right? If you want to store the negative number also, there should be a way, there should be a differentiation, there should be a process for me to do the conversion internally by using the binary numbers. That conversion we need to understand. My answer is correct, 255. 255, positive 255 I can choose by using the byte data type. But byte data types is giving us some privileges, saying that you should be able to save the negative number also. Not only the positive number, you as a developer, you should be able to store the negative number also. I have given you that privileges. How you are going to store, that is in your hands. That understanding is required. Right? Very simple, guys. So my calculation is very straightforward. I am just saying that by choosing 8 bits, of memory, these are the possible combinations. Starts from 1, 0, 0, 0, 0, 1, 2. It all goes till 1, 1, 1, 1, 1, 1. Right? If I just convert the last maximum number, the equivalent decimal number is 255. But this is a positive 255. But computer is saying that we should be able to store the negative number also. Please find a way. To understand that, we need to understand what the 2's complement. We need to understand what 2's complement. Let me write that here. 2's complement. After understanding this 2's complement, right, we can arrive to this conclusion. We can prove this. We can prove what? We can prove that the byte data type is meant to store the values from -28 to +27, +127. To arrive to this conclusion, we need to understand the 2's complement of a binary number. We will discuss about this 2's complement of a binary number tomorrow. And once again, one more thing. So these things will not be discussed anywhere in your subjects or anywhere in the Java book. These things are related to the data structures and algorithms, DSA concepts. Right? I am giving you the deep understanding about the internal things. You don't see this directly in the books. In books everywhere it says that, okay, these are the limitations, these are the maximum data that you can store by using the byte data type. But how they have arrived to this number, that answers you will not be able to find in the textbooks. I am going to explain you that each and every conclusion, like you will get such an explanation that instead of memorizing this, you will find these values, right? So I will keep it very slow. Tomorrow we will conclude this 2's complement, right? After understanding this 2's complement, we will able to come to the conclusion why it is from -128 to +127. Right? Because I can start this today, but it is going to take at least 20 to 30 minutes to understand this. But trust me, it is going to be very easy. Don't break your heads. Just try to understand what I said. Don't think out of the box. Okay? Just try to understand. So these are the data types, and data types are meant to store data. Right? Each and every data type is representing some kind of memory. Right? We are trying to understand how this memory can be utilized effectively. If you talk about byte is going to store. Just remember this. That's it. That would be enough. Byte is meant for 1 byte. Short is for 2 bytes. And int for 4 bytes, long for 8 bytes. Just memorize this. That would be sufficient. Don't memorize these values. These values I will explain you how they have arrived to this conclusion. Making sense? But still we have a lot of time. Right? If you have time, see these videos once again, how to do the conversion between binary to decimal. Don't think you need a visit. I mean, because these things are self-explanatory. I hope you have understood these things in your school days itself. Right? Any